Alright, I wanted to talk a minute about equivalent fractions, make sure that they're crystal clear in all of our minds because the chapter we've been dealing with deals a lot with equivalent fractions. And I don't know if you guys are recognizing that we've been dealing with equivalent fractions as much as we are. So first of all, when I think of equivalent fractions, I like to think of equal fractions. Equal. Two fractions that are equal in value. So one example of this, let's see. So one example to kind of show this equivalent fraction thing, how the values are all the same, I've drawn four equivalent fractions. So for this we can say that these are pizzas. So I've got 1/2. If you eat 1/2 of a pizza, if there are a pizza cut into 2 slices and I eat one, that is 1/2 the pizza. If it's cut into 4 and I eat 2, I have ate 1/2 the pizza. If it is cut into 6 and I eat 3, again, I have eaten 1/2 the pizza. If it's cut into 8 and I eat 4, I've eaten 1/2 the pizza. I've drawn this arrow here because I can keep on going. I can get out my pizza cutter and I can keep cutting smaller and smaller. And as long as my numerator always keeps this relationship of 1/2, then I've always eaten 1/2 the pizza. So the fractions are equivalent to 1/2. The value doesn't change. It is 1/2 the pizza. No matter how small the pizza slices are, it is 1/2 the pizza. So I've drawn a ratio table here just to point out that these ratio tables are equivalent fractions. So the reason I know they're equivalent fractions is for a ratio table to work, it always has to keep this fraction here of 2/3, always has to be the value. And so when I find these missing pieces, I went ahead and filled in these missing pieces real quick, and guess what? Every single one of these blocks, 20, 30, if reduced, would still have the value of 2/3. So they are equivalent fractions. I'm showing this because I now want to talk about, well, what if one of these is empty? What if one of these blocks is empty and I have to solve it? Well, I could solve this the same way as just, I'm going to show you a little method here in half a second, but I could use this method the same way. I'm just solving for an equivalent fraction for a missing piece. So let's get into this method I'm going to show you. I'm going to call it the fish method. Here it is. I know most of you guys can look at this right away and say, hey, I know what the answer is. But just for this, I'm going to still solve it. So I've got 2/20 is equal to 40 blank. I got to solve for that blank. So let me show you how this fish method works. So I'm going to draw a fish, and the key is my tail always has to end up, when I'm done drawing my fish, the very last tail has to end up where my blank is. Doesn't matter if my blank's here, my blank's here, my blank's here, or my blank's here. If I set these two proportions, these two equivalent fractions to each other, and I do my fish, and it always ends up there, it will give me the answer. Let me show you how this works. So, let me draw my fish. For my tail to work, I've got to start here, and it always goes times, divide, equals. Alright, I went ahead and wrote it out. 40 times 2 divided by 20 equals what I said. 40 times 2 equals 80 divided by 20 equals, equals 4. So I know this block is 4 or this block is 4. Those are equal or equivalent fractions. Alright, I know this was a long introduction to equivalent fractions, but now I'm going to get to what I wanted to talk about. How can I use these equivalent fractions to solve for percentages? Well, it's simple. A percentage is an equivalent fraction. Let me show you what I mean. So we know that I can write a percentage, percent over 100. This denominator is always 100 equals, and then I've can do a fraction here. So this fraction with my formula, I'm just going to go ahead and write is on top and of on the bottom. Is always going to be on top, and of is always going to be on the bottom. Also, so we know is also the part of the formula, and of is the total. So let me go ahead and give you a few examples of this. Alright, I went ahead and wrote down two different problems. First problem is 20% of 60, and second problem is 30% of 80. So I'm going to go ahead and I'm going to plug in what I know. Well, I know in this first one, I know I'm going to have two different fractions next to each other. I always put the equal sign because they are equal to each other. You don't necessarily have to do that. And I always know that the denominator is 100. I also know on that I'm going to do problem 1, and it is 20%, and the of is 60. Where does the of go? Well, right there it goes on bottom. So I'm going to go ahead and put it on bottom. Of is 60. So let's make my fish. Remember, I've got to end my fish right here where the question mark is, because I'm got to figure out what number that is. Times, divide, equal. Alright, I went ahead and wrote it down, and I gave the fish a cool green eye, so it looks like a cool fish. But, again, I went ahead and went 60 times 20 divided by 100 equals, and I know I did my fish right because I ended that last tail where my question was 60 times 20 divided by 100 equals 12. If I do the math, I know that missing number is 12. Number 2, again, I know I'm going to have my 2%. I know the denominator is 100 because the percent's always denominator. I've got my 30%, and I've got an of 80. Let's go ahead and make another fish. Times, divide, equal. Oh, I did my fish right. I ended where I needed to. Alright, again, I ended up writing this one out. Oh, I forgot to give my fish an eye. Well, the fish doesn't need to have an eye by any means. So I've got 80 times 30 divided by 100. 80 times 30 divided by 100 equals, if I do the math, it equals 24. So 30 hundredths and 24 eightieths are equivalent, and I found the answer. It is 24. Does this just work with these kind of problems? Nope. I can solve for other missing numbers. Let me show you what I mean. Alright, I wrote down two different problems. This time, it says 25% of what number is 30? Well, the of is simple. Of is what number? Well, what number is of? We don't know. It's what number. What number, we could also do a question mark. But it is telling us the is. So we've got the part this time, and we don't have the of the total. So I'm going to go ahead and fly through these fairly quickly. So I've already set up 3, and I've put up my 2 fraction bars. So the denominator is always 100. I'm going to go ahead and do that on 4 too while I'm at it. Number 3, the percent is 25%. Of what number? I don't know what of what number. It's a question mark. Is 30. Well, I can see here is goes on top. Is 30. So this time my fishtail needs to end here for it to be right. So I'm going to start on the 30 and go 30 times 100 divided by 25 equals, so 30 times 100 divided by 25 equals 120. So I know this is 120. So I'm going to run out of room, so I'm going to separate these two. I write a little bit too big. So let's go ahead and go on to 4. I know my percent is 18. Of what number? Well, I don't know what number. It's what number. But I do know the is 25. 25 goes on top. So we've got, again, make my fish times divide. Make sure my tail ends where I need the answer. So I got 25 times 100 divided by 18 equals 138.8. So what number is 18% of what number is what? Well, my what number is 138. Bloop, bloop, bloop. 138 was that missing number. Alright, real quick as a review, I just wanted to show you that we've been using equivalent fractions a lot, and hopefully you recognized it. But also one thing that we could do is we could solve for percentage as well. I just want to show you this real quick. So this would problem read something like, what is 8/9? What is the percent of 8/9? So we could do the same thing. We're solving for percent. 100 times 8 divided by 9 equals, whoa, sorry about that. One more time. 100 times 8 divided by 9 equals, 100 times 8 divided by 9 equals 88.9%. So I know that that would be, I'm just going to call it 89%. So, little review, is also equals part of also equals total, and something that I don't know if you picked up on, but my fish can either swim this way or it can swim this way. If I have a fish that is swimming down or up, I have done my fish wrong. My fish can only swim in 2 different directions. So, anyways, little review. I hope that this fish method helped some of you guys out.